Welcome back, students. In this video, we're going to continue naming by naming bicyclic compounds. Let's start our discussion by talking about what bicyclic compounds are. So we've already discussed cyclic compounds, which is when you have a ring. And bicyclic compounds are compounds where there are two or more rings in the structure. I want to look at the first structure that I've drawn here on the left and show you where the two rings are. Here's one ring that I'm highlighting in yellow, and here is a second ring that I'm highlighting in blue. I want you to take a moment and recognize that when these two rings are joined, they share a carbon here and here. These carbons are going to be really important. These carbons have a specific name. These are called bridgehead carbons. For the second structure on the right, this one is a little bit more confusing, and I want to redraw it off to the side first and see if we can't make sense of it. The first thing that I want to do is highlight this part in yellow and show you that this part is the beginning of our ring. And that ring is attached to this, where there's not really supposed to be spaces there. So let's make that nicer. And then this kind of six-membered ring, which is drawn a little bit differently. I've purposefully drawn the bond here and the bond here going kind of up instead of the way we would normally draw cyclohexane. And then we have a third section that I'm going to draw in a different color. So this third section is connecting our carbon here and our carbon here, and there's one carbon between them. Notice how this red section I drew through the blue bond. And the reason that on the structure I've drawn in black, there's actually a space where I will highlight in blue, right? There's a space right there. Because whenever any lines cross, you're actually saying that there's a carbon there, and there's not a carbon there, right? It's just really hard to draw this on a two-dimensional sheet of paper because it is very much a 3D structure. So what you're imagining is a cyclohexane ring where there is a one carbon bridge coming up and down, connecting, say, carbons 1 and 4 on our cyclohexane ring. Now that we have made sense of that gap and why we're drawing the gap that I've colored in blue, I want to draw in and highlight the rest of the parts of this ring. I'm actually going to erase that gap so that I can say that there's another part to my ring over here. And then there's that third part that goes up and down, and let's highlight that in a different color. This is a bicyclic that has 3 parts to it. So instead of 2 fused rings, this is something that's called bridged because it has that bridge. And again, we're going to have bridge heads here as well, where all 3 of our bridges have a common carbon is where our bridge heads are. So there's a bridge head here and there's a bridge head here. Now that we have some terminology down and we have looked at how our bicyclic compounds are drawn, let's start talking about naming them. When we name our bicyclic compounds, what you need to do first is find the bridgehead carbons. And that's why we spent so much time on the earlier slide looking at how these are arranged. One thing that might be helpful as you're starting is to go ahead and highlight the different rings. So here's one ring, and here's the second ring. And once you highlight those 2 rings, The places where the rings have a carbon in common are your bridgeheads. And you should always have two bridgeheads. So here is one and here is the other one. So I found my two bridgeheads. Next, your requirement is that you number the largest cyclic part first. The part that I've highlighted in yellow then gets numbered first because if we start at a bridgehead, so imagine you are here at this bridgehead, and you walk along the yellow pathway until you get to the other bridgehead, then you have 1, 2, 3, 4 carbons before you show up to the next bridgehead. Once you get to that second bridgehead, then you number the next largest bridge, right? So we numbered the largest first, and then you go to the next one. So here, this is 1, 2 carbons in that ring. I've redrawn the structure above to show you how this is a fused ring without a third bridge. If we highlight and focus on those bridge heads again, we've already numbered the yellow bridge. We've already numbered the green bridge. Now, the third location is going from the bridge head, say this one, directly to this one. And there's no stepping stone between them, right? There's no carbons between those two bridge heads. They're just directly connected to one another. And that's what makes this a fused bicyclic instead of a bridged bicyclic. So we've gone through a bunch of pieces and we're not done yet. We need to figure out how to put all these things together. All right, so we chose our bridge heads, we found them. We chose a bridge head and then moved along and counted how many carbons were in our biggest bridge. And then we went to our next biggest bridge, and then we went to the smallest bridge. Before we take into account the substituent, I just want to write the rest of what the name is going to be. So the part that I want to write is mimicking what we're seeing down here, where we're going to start with the part that says bicyclo because this is a bicyclic structure. We start by saying bicyclo, and then in brackets are the numerical values of how long each bridge is. The yellow bridge has 4 carbons in it. Notice how we're not counting the bridgehead carbons. So the yellow bridge, if you start at bridgehead, the next carbon that's part of that bridge is carbon number 1. There's 1, 2, 3, 4 carbons in that bridge before you reach another bridgehead. So where I'm seeing these X's in my pattern is the numerical value of how many carbons are in each bridge. The longest bridge is always listed first, and in this case, the longest bridge is 4 carbons. Then you go to the next bridge. The next bridge has 1, 2 carbons in it, so we put a 2 here. You always need 3 numbers in brackets. Therefore, if you have a fused ring, like we have here, the last bridge is 0 because there's no carbons between the 2 bridgehead carbons. We close the brackets and we write the parent. Now the parent is going to include the total number of carbons in the bicyclic structure, excluding substituents. If we redraw this really quick, just so that we can keep it not so messy, and we start at one of our bridge heads. That's 1, 2, 3, 4, 5, 6, 7, 8. There's a total of 8 connected carbons in here where the substituent is exterior to the bicyclic ring system, and we're not counting that as part of our parent. So the bridge heads count when you're naming the parent, but the bridge heads are not included in this part that I'm highlighting in green. When we name our parent, we have 8 total carbons, so that's oct, and then we end with ANE because there's all single bonds here. That's how you would name it without a substituent. but this particular example does have a substituent, so let's add that on. If you are having a substituent, the order of operations is still that you have to start at a bridgehead carbon when you start numbering, and that you have to number the largest bridge first, followed by the next largest, followed by the smallest. And within that context, you have to number to get your substituent the lowest lock-in. So the other rules take priority. You have to start at a bridgehead. You have to number the largest bridgehead first. The largest bridge first. Really, there's only two ways for us to start numbering this compound. I'm going to start numbering it one way, where I'm going to call this 1, 2, 3, 4, 5, 6. Remember, I have to number the largest bridge first. Then I come across and hit 7. In this set of numbering, I would get a 7-methyl. If I erase these numbers and start at the other bridgehead, which we can do right now, let's start numbering at the other bridgehead, 1, 2, 3, 4, 5, 6, 7, 8. This is going to get us an 8-methyl. What's smaller, a 7 or an 8? Well, obviously the 7. We're going to stick with the first way that we numbered and call this 7-methyl. One of the things that people struggle with naming bicyclic compounds is that it's almost like there's two numbering systems. The first numbering system is what you'd use to figure out the numerical values that need to be in the place that I've highlighted in green. The second numbering system is what we use when we start looking at the structure and where the substituents sit. Let's go ahead and do a little bit of practice. For these two structures, I want you to take a moment and come up with the name for each of the bicyclic compounds, and then come back and compare with me when you're ready. For this first one, I've already gone ahead and boxed my bridgeheads in blue and highlighted my larger bridge in yellow and my smaller bridge in green. When we start assembling this name, we're going to start with bicyclo. Then we put in brackets the size of each bridge. Remember that the bridgeheads don't count as part of the size of the bridge. You're starting at a bridgehead and you're numbering 1, 2, 3 until you get to another bridgehead. The first biggest bridge is the yellow one that has 3 carbons in it. The second bridge is the green one that has 2 carbons in it. The final bridge is not there because this is a fused set of rings. If we were to go directly from one bridgehead to another, I'm going to highlight that in blue, and it kind of looks green. That is going to take no carbons between the first bridgehead and the top bridgehead. So that means we have a 0 here. Then we need to end with our parent. When we end with our parent, we're putting in all of the carbons in the bicyclic structure. That means we're including the bridgehead carbons. One nice way to know that you've done this correctly is if you count all the carbons in your bicyclic ring, and you also count how many carbons are in brackets, and you add 2, they should be the same number. In this case, you have a total of 7 carbons, so we call this heptane. Now for the second one. In the second one, bridged rings are really a lot harder to visualize. I've gone through and I've done the same thing where I've pointed out my bridgehead carbons, I've labeled or highlighted my 3 different bridges. And I'm going to start again with bicyclo. Then I come with brackets. I'm going to start numbering. If I start at one of my bridgeheads and then go 1, 2, 3, 4, and I get to here, that has 4 carbons. Then I go to my next largest bridgehead, or I'm sorry, my next largest bridge, which is 1, 2, before I get around to the other bridge head. So there's 2 carbons in that one. And the bridge that I've highlighted in blue starts here, goes up and then down. So there's 1 carbon right here in that bridge. So we will end with a 1. We can go through and count all of the carbons in that structure that are part of that fused or bridged system. And in this case, it is a little weird because when you count all of the carbons, you do have to kind of like pop up at the end and hit that one that's in the single carbon bridge. I'm going to show you what I mean by that, but first I'm going to erase our other numbers. When we look at counting all of the carbons in the system, what we're trying to do is count all of the carbons that are part of the pathways that connect the bridgeheads. If we start at a bridgehead, let's do 1, 2, 3, 4, 5, 6, 7, 8, and then you get to 8. And the blue bridge hasn't been accounted for, and that's when you have to pop up and just call that 9, which is totally different than any of our other naming that we've done, because if we look at the other naming that we've done, you weren't allowed to like skip over a carbon. But here it's different because all of the carbons are connected to one another. It's just you can't come in and recount this carbon. And then we end with our final parent, which is going to be nonane. Go ahead and make sure that you're trying some more examples of these with substituents so that you're seeing all the different layers of difficulty for these problems. Let's wrap up. In our last video, we looked at nomenclature of cyclic alkanes with substituents. And then in this video, we looked at naming bicyclic compounds also with substituents. Those bicyclics can be really tricky because of the way that they are drawn. It's hard to make sense of. If you have a molecular model kit at home, it might be beneficial for you to build some bicyclic compounds so you can really hold them in your hand and see what the picture on the page is meant to be telling you. Thanks so much for watching. This is Katoni signing out.